Hello everybody. Here's a nice and challenging geometry problem which can be solved using just elementary geometry. The problem states that number 1. A quadrilateral ABCD has its side BC equal to twice of AD. Number 2. BC is parallel to AD. Number 3. AB is perpendicular to BC and AD. Finally, number 4. The area of the quadrilateral is 18 units. The problem posed by the question is to find the radius of the inscribed circle which touches all its sides. I would recommend you to pause and try to solve it by yourself first and then watch the video. Now, the best way to solve a geometry problem such as this is to draw all the lines that connect each and every point. So let's first draw the lines from the center of the circle to the points that it touches on the quadrilateral. Now let's label all the points. One thing that should be clear is that all the angles of the sides of the quadrilateral against the radii of the circle are 90 degrees, as all of them are basically tangents to the circle. With all the angles given, it is now very evident that EABF is a rectangle. As a result, EF is equal to AB. Since EF is equal to EO plus OF, EO and OF are both radii of the circle. AB should be twice the radius, which from now on I will be calling R. For this part of the problem, we have to draw two more lines, OD and OC. Let's start by labeling the sides. Let ED be B. But if ED is B, then this part should also be B. This is because they are the intersecting tangents of the same circle. Similarly, let CF be A. And hence this part will also be A for the same reason. The base of the quadrilateral we already found was 2R, and because of the properties of a rectangle, these two sides are R. From here we can start getting our equations. We get our first equation from the information we were given. BC is equal to twice of AD. In place of BC, we can substitute A plus R, and in place of AD, we can substitute B plus R. We get that A is equal to 2B plus R. We get the second equation from this simple observation. ABCD is a trapezium, as AD is parallel to CD. We know that the formula for the area of a trapezium is x plus y whole over 2 times h, where x and y are the parallel sides and h is the perpendicular distance between the parallel sides. Rx is b plus r, ry is a plus r, and rh is 2r. Therefore, putting our values in the equation, we get that b plus r plus a plus r whole over 2 times 2r is equal to 18. Since a plus r is twice b plus r, we can substitute a plus r with 2 times b plus r, simplify, and get that b plus r is equal to 6 over r. To get our third and final equation, we need to focus on this part of the diagram. Let's draw a line perpendicular to the larger parallel side, separating the quadrilateral into a right angle triangle and a rectangle. The hypotenuse of the triangle is a plus b. The base of the triangle will be equal to the base of the quadrilateral, 2r, and the height of the triangle will be equal to the length a plus r minus the length b plus r, which is equal to a minus b. Now, using the Pythagoras theorem, we get that a plus b whole square is equal to a minus b whole square plus 2r whole square. We simplify to get that ab is equal to r square. Now comes my favorite part of this question, the algebra. Let's first write our three big equations. Then let's start with equation Roman 2. B plus r is equal to 6 over r. We can transpose the r to the other side, then make the denominator same, giving us that b is equal to 6 minus r square whole over r. Now we can substitute this value in equation Roman 1, giving us that a is equal to twice 6 minus r square whole over r plus r. We can simplify to get that a is equal to 12 minus r square whole over r. The last thing to do is to substitute the value of a and b in equation Roman 3. We get that 12 minus r square whole over r times 6 minus r square whole over r is equal to r square. We can multiply the r's in the denominators and transpose them to the other side to get that 12 minus r square times 6 minus r square is equal to r to the power 4. Here the trick is to substitute 6 minus r square with u. Therefore the equation becomes 6u plus u square is equal to 36 minus 12u plus u square. This easily solves to give us that u is equal to 2. Putting u back in terms of r, 6 minus r square is equal to 2 or r is equal to 2. So that's our answer. The radius of the circle is 2 units. I hope you enjoyed this problem because I certainly did. Till next time.